Okay, so real world example, find the angular and linear speeds. So we have a bicycle messenger rides the bicycle, shown. So we have a bicycle and the diameter of the wheel, so that is the diameter, is 30 inches. During one delivery, the tyre rotates at a rate of 140 revolutions per minute. So this means this wheel just turns 140 times every minute. And then we're asked to find the angular speed of the tyre in radians per minute. Now, because each rotation is 2 pi, so the distance around this circle, the angle is 2 pi. And it's going to do 140 revolutions every minute. So that's going to be 140 multiplied by 2 pi. So this is 280 pi, and it's in radians. So the formula is omega, and then this is our angular speed formula, and it's divided by pi. So we're going to just substitute in the value that we found. So our 280, and then our time is minutes. So we'll have omega is going to be 280 pi divided by 1 minute. Now we need to use this information. Okay, so if we divide, put this into our calculator, 280 times pi divided by 1 minute, we will have the angular speed, which is this, is equal to 879.6 radians per minute. So on part of the trip to the next delivery, the tyre turns at a constant rate of 2.5 revolutions per second. So this time, 2.5 revs per second. And it says here, find the linear speed. So let's highlight the information. So we've got 2.5 revolutions per second. And then we need to find the linear speed in kilometers per hour. So 2.5 revs per second, and each revolution is going to be times 2 pi. So this is going to be 2.5 times 2. So this is going to be 5 pi. And this is going to be radians. Now, for the linear speed, we're going to have the arc of the tyre. So this is the arc length divided by the time. So this is going to be our linear speed formula. And we can replace the arc length because we know that the arc length is actually the radius times the angle. So this is going to become the radius times the angle divided by the time. Now our circle, our tyre, okay, so we've got a diameter, and this is in inches. So this was 30 inches. So this means our radius, we divide by 2. So our radius, we divide by 2. Not very straight, unfortunately. Let's try one more time. So our radius is 15 inches, but we need it in centimeters because we need to convert to kilometers. So the conversion factor is 2.54 centimeters is 1 inch. So therefore 15, well, let's write it the other way, 15 inches will be 38.1 centimeters. So we now need to write the radius, okay, in centimeters. So that's 38.1 centimeters times our angle. And this is our angle. So that's going to be 5 pi. And the time, I'm going to divide it by time. And the time is going to be in seconds. So that's going to be divided by 1 second. Now, if you multiply this together, this is going to be 190.5 pi, and it's in centimeters. And this is going to be 1 second. Now, we need to change these measurements. So this was what our one conversion factor that we had. So we need to think about other. So when we talk about time, we know that 1 hour is 60 minutes. We know that 1 minute is 60 seconds. We also know about centimeters. So 100 centimeters is 1 meter. And we know that 1,000 meters is 1 kilometer. So we're going to need to use this information. So let's just move this down a second. Okay, so I'm just going to rewrite this by here. So 190.5 pi centimeters, and this is over 1 second. So what we need to do is multiply by 1. So we're not changing our formula, but we're converting. So we need to multiply something. So we need to have seconds here. So if we have 60 seconds, this is equivalent to 1 minute. So if we divide this together, it'll give us 1. So it doesn't change. So this is multiplied by 1. Now, when I do this, it means my seconds can cancel. Now, when I look at my questions, I need in kilometers per hour. I don't want my answer in minutes. So I need to multiply. So I need minutes. So 60 minutes is equivalent to 1 hour. So this is multiplied by 1. So this means I can simplify my minutes. Now I need hours, and I've got hour here, so this is okay. So far I've got centimeters, and I've got some numbers here, and I've got hours. Now I don't want centimeters, I need it to be in kilometers. So I need to change my centimeters. So if I multiply, but this time I need centimeters on the bottom because I need it to cancel. So 100 centimeters is going to be 1 meter. And this means that I can cancel out my centimeters. Oops. So the 100 stays, just the units. We're just cancelling the units. So a meter. So I don't want a meter, I need a kilometer. And the kilometer has got to be on the top because it's kilometer divided by hours. So hours on the bottom, that's okay. So now if I multiply by 1 kilometer, kilometer is 1,000 meters, and I can cancel my units for meters. So I have a pi. Now I also have a kilometer, and I have an hour. So my answer is going to be a number multiplied by pi, and then it's going to be kilometers per hour. So I can now multiply out my numbers. So I'm going to multiply 190.5 multiplied by 60, multiplied by 60, multiplied by 1, multiplied by 1, divided by 1 times 1 times 1 times 100 times 1,000. And if I do that, my final answer is going to be, I'm going to convert that then, so I'll have 21.6 kilometers per hour. So this is the linear speed.